This is the detailed instructions on how to do the problems on the practice assessment sections 1.5 to 1.8. Remember, these are the ones you want to do on your own to see what you remember and don't remember. I have tagged them with what section they come from, so if you need to go back and watch a video and review, you can. However, I give pretty detailed explanations in these videos as well. Problem number 1 wants you to write the slope-intercept form of a line that is parallel to 2x plus y equals 1 and passes through -3, 2. First of all, remember slope-intercept form is y equals mx plus b. We like slope-intercept form the best because if we're going to utilize our graphing calculator to help us graph, we need our equation in this form. In order to write the equation, you need 2 pieces of information. You need to know the slope of your line, and you need to know the y-intercept, which is b. All I told you is that my new line is parallel to the equation 2x plus y equals 1. In geometry and in algebra, we learned that 2 lines are parallel if they never meet, they never cross each other. Algebraically, that means that the 2 lines have the same slope. That means the number in place of m is the same. The thing is that this equation I gave you is not in slope-intercept form. So in order to find the slope of it, we're going to have to solve for y. In order to solve for y, we're going to subtract 2x from both sides. The new equation is y equals -2x plus 1. 1 minus 2x is not -1x. Remember that in order to combine them, they have to be something called like terms. Since a term with an x and a term without an x are not like terms, you can't combine them. So the slope of this line is -2. Since I just said lines that are parallel have the same slope, the slope of the line parallel to it is also -2. So I know the slope of my new line. The only other piece of information they gave me is that the line passes through the point -3, 2. So I'm going to write down passes through -3, 2. Well, how am I going to find the y-intercept? Well, there are 2 ways of doing this. I'm going to show you the way that I like to do it, and I'm going to show you another way. And your algebra teacher may have shown you both. In slope-intercept form, where I now know that the slope is -2, when I give you a point that lies on the line, I'm giving you an x and a y value. Remember, in an ordered pair, the first number is called the x-coordinate and the second number is called the y-coordinate. So I could plug in 2 for y, and I can plug in -3 for x, and then solve that equation for b. So 2 is equal to, multiply, +6 plus b, and then I would subtract 6 from both sides, and find out that b is -4. So the equation is y equals -2x minus 4. That's the equation of the line that's parallel to 2x plus y equals 1 and passes through -3, 2. But there's another way of doing this. There's another form of writing the equation of a line called point slope, and you may have learned this one as well. If you did, then you would plug in -3 for x1 and 2 for y1. So y minus 2 is equal to, the slope, m is -2, x minus -3. When you see 2 negatives next to each other, you know to change it to a positive. And then you would distribute. So y minus 2 is equal to -2x minus 6. And then you would add 2. And you would still find out that y is equal to -2x minus 4. I want you to notice that, both of these methods basically took the same amount of work. The nice thing about problem 2 is we're actually going to do the same exact process over again. So if you're just kind of starting to understand it in problem 1, we're going to do it again in problem 2. The only difference in this problem is that my new line is perpendicular to 4x minus 2y equals negative 2. You know from geometry that two lines are perpendicular if they form a right angle. In algebra, we learned that two lines are perpendicular if their slopes are opposite reciprocals. Opposite reciprocal means you change the sign. Reciprocal means you flip the fraction. So first, I need to find the slope of this line. So I need to solve this equation for y. So first I'm going to subtract 4x. I get negative 2y because that minus sign, yes, it is the same thing as a negative, is equal to negative 4x minus 2. And then I'm going to divide every term by negative 2. So y is going to equal, two negatives make a positive, 4 divided by 2 is 2, and negative 2 over negative 2 is positive 1. So the slope of my old line is 2. That means the slope of my line perpendicular is negative 1 over 2. Opposite reciprocal means change the sign, flip the fraction. Well, now that I know the slope of my new line, so I know it's y equals negative 1/2 x plus b, the only thing I don't know is my y-intercept. You have two ways of doing it. So it passes through the point 1, 4. So one of the things you can do is this is x and this is y. Plug in 1 for x, 4 for y. 4 is equal to negative 1/2 times 1 plus b. So 4 is equal to multiply negative 1/2 plus b. And then I'm going to add a half. If it helps you to turn this into a decimal, that's fine. If you don't know how to change decimals back into fractions on the graphing calculator, it's very easy. You just press the math button and then hit enter twice. So I'd prefer you not tell me that 4 plus 1/2 is 4.5. We don't normally use mixed numbers in upper level math. So you can tell me it's 4.5. I'm okay with that. Or if you type in 4.5 into the graphing calculator and hit math, and then you hit enter twice, it'll tell you that it's the improper fraction 9/2. So the equation is y equals negative 1/2 x plus 9/2, or 4.5. Now, the other way of doing it was using that point slope form. We would have gotten the same answer. So y minus y1 equals mx minus x1. It's just we would have plugged in our 4 here and our 1 here. So y minus 4 is equal to negative 1/2 x minus 1. And then I would distribute. So y minus 4 is equal to negative 1/2 x plus 1/2, because two negatives make a positive. And then I would add 4 to both sides, and look what ends up happening. I get the exact same answer. Sometimes we just want to know if two lines are parallel, perpendicular, or coinciding. Coinciding means you have two equations, but when you graph them, it turns out they're the exact same line. So you actually only see one line on the graph. It doesn't have to be any of these. You can have two lines that are none of these three. And I claim that if you have all of your equations in slope-intercept form without graphing, you can tell me if two lines are parallel, perpendicular, or coinciding, or none. So let's look at A. The two equations are y minus 8x plus 1 equals 0. And the other one is y minus 8x minus 12 equals 0. So in order to determine if these two lines are parallel, perpendicular, coinciding, or none of these, we're going to put them both in slope-intercept form. Well, now I'm actually going to do more than one step. I want y to be by itself, so I'm not only going to add the 8x, but I'm going to subtract the 1. So these go away, and you're left with y is equal to 8x minus 1. For the other equation, you're going to add the 8x, and you're going to add the 12. So they go away from here, and you're left with y is equal to 8x plus 12. So I want you to notice, they have the same slope, but the y-intercepts are different. That is parallel lines. Now let's look at B. In B, my two equations are y equal 3x minus 2, which is already in slope-intercept form, so that's nice. And the other equation is 3x plus y equals 2. So we're going to solve for y by subtracting 3x. So y is equal to negative 3x plus 2. All right, so first I check their slopes. Their slopes are different. The second the slopes are different, it's none of these. Automatically. Remember that two lines are perpendicular if their slopes are opposite and reciprocals. So these two slopes are opposites, but they're not reciprocals. All right, let's do this one more time. In problem C, my first equation is y equals 5x minus 12, and the second one is 2x plus 10y plus 10 equals 0. So the first equation is already in slope-intercept form. We got to change the second one to slope-intercept form. So in order to get y by itself, the first thing I'm going to do is I'm going to subtract the 2x, and I'm going to subtract the 10. So I'm going to be left with 10y is equal to negative 2x minus 10. Then I need to divide everything by 10 and reduce fractions. So this is y is equal to negative 2 over 10 reduces to negative 1 over 5 minus 10 over 10 is 1. I want you to look at their slopes. Those are opposite and reciprocals. Therefore, they must be perpendicular. Problem number 4 was from section 1.6, which was something I covered in class. So in order to find the linear regression equation, we're not going to do it by hand. You may or may not have learned to do it by hand in Algebra 2, depending on who you had as a teacher. We're never going to do this by hand. The reason is because the graphing calculator will give us the most exact answer. So remember that if you have a table of data where the first list is years, the only time you do this is if the first list is years. We're going to call these years 0, 1, 2, 3, 4, 5, and 6. The reason we do that is because sometimes the years will give the calculator something called a data overload error. That means that the numbers are so big it can't compute. So we're going to call this 0, 1, 2, 3, 4, 5, 6. So when we go find the linear regression on the calculator, remember that you're going to go to Stat, which is a button on the calculator, and then it's already highlighted on number 1 edit. You're going to put the years in list 1 and the visitors in list 2. If you need to clear old data, you put the cursor on L1, press the clear button, and then press down. Put the cursor on L2, press the clear button, and press down. If you accidentally press the delete button, it will make the list go away. It is very easy to come back. You just press Stat, number 5, Enter, and then it'll come back. So once you put this data in, if all we care about is the equation and not the graph, then you go back to Stat, and then arrow 1 to the right to Calc, and you go down to number 4, which is Lin Reg AX plus B. And then if you have a new operating system on your calculator, you'll probably have to hit enter a couple of times to get the equation. Otherwise, you should just press enter and round the decimals off, and you should get y is equal to 1,115.9x plus 19,522.0 approximately. The next thing is this a good equation or not? Well, look at your r value. Remember, if r is close to 1 or negative 1, it's a good equation. So if you have r's in the 0.9s, it's probably a really good equation. If your r is in the 0.8s or 0.7s, we call that moderately strong or moderately weak. We don't, it's an okay equation, but it's not awesome. The awesome equations are the ones where r is in the 0.9s. Now we want to use this equation to predict the number of overseas visitors in 2011. So now you kind of have to go back up here to your table and go, okay, well, 2000 was year 6. So 11 years after that is going to be year 17. If you plug 2011 in for x, you're going to get the wrong answer. So you're going to do 1,115.9 times 17 plus 19,522. And I want you to watch where I round this number off to. I round it to 38,492. Notice that I did not put a point something at the end. One of the things we have to look at is what kind of information are we getting from this problem? It's the number of visitors in 2011. That means people. Can you have a decimal number of people? Are there 24.3 people in a class? Absolutely not. So when you look at the problem, remember to ask yourself, what kind of data are we getting? And that's going to tell you how to round. If the data is giving you an output of people, you would never use a decimal. If the data is giving you an output of money, you would round to 2 decimal places. This was called a piecewise function. It was called a piecewise function because we're only going to look at pieces of 3 graphs. So there are 2 things you need to know. One of them is that this is 3 independent equations that we're going to graph. We're going to graph y equals -1, y equals -3x, and y equals x plus 4. I'm going to graph them by hand, but you can always use your graphing calculator and the table function to get the ordered pairs to help you to graph. The first equation, y equals -1, is a constant function. Because it has no input, every value is an output. Therefore, we say it's a horizontal line. It is the horizontal line through y is 1. The problem is we're not going to look at that entire graph. We're only going to look at the part where x is less than -2. So think about how you graphed x is less than -2 on a number line back when you learned this in Algebra 1. In Algebra 1, you would start on a number line, you would find -2, it would be an open circle on -2, and the arrow would point to the left because the little inequality arrow is like an arrow pointing to the left. Guess what? That red graph at the top with the open circle and the line going to the left is the same thing I'm going to see on this red line on the coordinate plane. I'm going to put an open circle at -2 on that line. Well, where's -2? -2 is right here. And then the arrow from it is going to go off to the left. And that means that everything that's to the right of it disappears. Well, look, that graph looks just like the one on the number line. Interesting. All right, now let's go look at the second graph. The second graph, I'll put in a different color, is -3x. It's the same as -3x plus 0. So the y-intercept is 0, and the slope is -3. That means you go down 3, right 1, put a dot. Down 3, right 1, put a dot. You can go the other direction too. You can go up 3, left 1, put a dot. Up 3, left 1, put a dot. So that's my line. Except that I'm not going to look at all of that line. I'm only going to look at the line from -2 to 2. How does that work? Well, let's go back to our number line and how we graphed this in Algebra 1. This was called a compound inequality. And the way that it worked was you put an open circle on -2 because the little inequality symbol next to it does not have the line underneath. And you would put a closed circle on +2, and then you would just connect the dots. Well, guess what? This graph, the green graph on the coordinate plane, is going to look exactly the same. I'm going to find -2 on the green graph and put an open circle. I'm going to find +2 and where it hits my graph on the green line. And then anything that's not between them gets erased. So the graph looks exactly the same as it did on the number line. The only difference is that the number line was kind of horizontal and my green line's diagonal. But if you turn it a little, it looks the same. All right, let's do this one more time. Y equals x plus 4. The y-intercept is 4, so you start here at 4 on the y-axis, and the slope is 1. So you go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, forever and ever, and then, here's your line. The only thing with that line is that if you think about the inequality here, x is greater than 2. That means an open circle on 2 with an arrow pointing to the right. So I'm going to start at wherever 2 is on the x-axis and put an open circle, and then my arrow goes to the right, and anything else after that just gets erased. So this is what my piecewise function looks like. If you want to put it in your graphing calculator to check it, you would put in y1 equals -1, division sign, parentheses, x is less than -2. Remember, the inequality symbol is under second math. To graph the second one, you would graph y2 is equal to -3x, division sign, parentheses. The compound inequality has to get separated into -2 is less than x, and x is less than or equal to 2. The and function was also under second math, but you had to arrow one to the right to logic. And then in sorry about that. And then in y3 equals, you would type in x plus 4, division sign, parentheses, x is greater than 2. The only thing the graphing calculator does not tell you is if the circles are open or closed. That's why we like to graph it by hand instead, and then go back and check on our calculator later. The last problem, y is less than the absolute value of x minus 2, comes from section 1.8. It is on graphing inequalities. And instead of giving you a linear inequality, which you spent a lot of time in Algebra 1 doing, I decided to give you an absolute value inequality. Absolute value graphs, the ones that have the absolute value bars, when you graph them will always be a V. Since inequalities are the problems that get shaded, how do you know when you graph a V where you shade? Well, you're either going to shade inside the V or outside the V. Usually it's inside the V if you have the greater than symbol, and it's going to be outside the V if you have the less than symbol. All right, so let's graph this V. If you need help, just put y1 equals the absolute value of x minus 2 in your calculator. If you have the new operating system, it'll actually pop the absolute value bars up. And then go to the table function, second graph, in order to find the ordered pairs. I know from Algebra 2 when we studied absolute value graphs that this is a V that's been shifted 2 units to the right. So I know that I'm going to start at 2, and then all my points are going to go up 1 to the right 1 in this direction, and then they're going to go up 1 to the left 1 in the other direction. Next, notice that the inequality symbol is the one without the line underneath. That means that instead of solid lines, these are going to be dashed lines. So I'm going to go back and make these dashed. Oh, my little dots aren't coming. There we go. And then since the symbol is less than, that means that we're going to shade everything below the V. If you're not sure why that's where we shade, test a point. Test the origin, 0, 0. What happens if you plug in 0 for X and 0 for Y? Do you get a true statement or a false statement? Well, 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. Is 0 less than 2? Yeah. And we always shade on the true side. So that's the answers to the practice assessment 1.5 to 1.8. If you need additional help with any of these sections, go back and watch the video lectures on EduCreations or on YouTube for any of sections 1.5 to 1.8. I cover the most important details and I cover them in great depth.